You know, when you look at a forest or a coral reef, have you ever wondered how it all works? There's actually a hidden structure to it all, a beautiful, logical shape to life in any ecosystem. And today, we're going to uncover that shape by diving into the world of ecological pyramids. All right, so here's our game plan. We're going to start with a really strange puzzle from the ocean. Then we'll track down our first big clue by figuring out what biomass even is. We'll see how scientists actually collect their evidence, organize it all into three different kinds of pyramids, and then finally we'll put all the pieces together to solve that mystery. So let's just jump right in. The best way to really get how a complex system works is to start with a puzzle, a moment where it seems like nature is just breaking its own rules. Okay, just think about that for a second. How can you have more predators by weight than the food they eat? That's kind of like having a tiny little slice of pizza that somehow feeds a whole huge family, and there's still pizza left over. It doesn't seem to make any sense. But I promise, by the end of this, you'll know exactly how it happens. To crack this case, we have to start with one really important idea. This one concept, biomass, is pretty much the key that's going to unlock this entire puzzle for us. So what in the world is biomass? Well, simply put, it's the total weight of all the living stuff in a specific area. But here's the catch. We only measure the dry mass. That means scientists take a sample, they put it in a low-temperature oven to get rid of all the water, and then they weigh what's left. That stuff that's left over, that's the biomass. It's the actual organic matter that life is built from. And scientists have two main ways to measure this. They can just weigh it, which gives them grams per square meter. That's the mass part. Or they can measure the energy that's stored inside it, which they measure in joules per square meter. It's really just two different ways of looking at the exact same thing, how much life is packed into a certain space. Okay, but how do scientists actually measure this stuff out in the real world? Well, it involves some pretty clever techniques to get the raw data they need to build these amazing ecological pyramids. The first method is really straightforward. It's all about measuring that dry mass directly. First, you go out and collect your samples, say a square foot of grass. Second, you dry it out very carefully in an oven until all the water is gone. And finally, you just weigh what's left. That gives you the biomass for that little patch, and you can use that to estimate the biomass for the whole area. Simple, right? Now, to measure the energy, scientists use this really cool method called calorimetry. It's pretty amazing. They start by completely burning a dried sample. Then, they use the heat from that little fire to warm up a very specific amount of water. And by measuring exactly how much the water's temperature changes, they can calculate precisely how much energy was stored inside that little piece of life. Okay, so now we have all this data on mass and energy. What do we do with it? How do we organize it so we can see the bigger picture? Well, scientists use this awesome visual tool called an ecological pyramid. And there are three main types, with each one telling us a slightly different story. First up, you've got the pyramid of numbers. This one is super simple. It just counts how many individual critters are at each level of the food chain. But this one can get a little weird. For example, you could have one single massive oak tree at the bottom, supporting hundreds and hundreds of tiny caterpillars. If you drew that out, it wouldn't look like a pyramid at all, would it? It'd be all skinny at the bottom and wide in the middle. So to get a clearer view, we use the pyramid of biomass. This one shows the total dry weight of organisms at each level. And this one almost always looks like a proper pyramid. Wide at the bottom, pointy at the top. And why is that? Well, as you move up the food chain, a ton of mass is lost as waste or is burned for energy and just breathed out as CO2. But the most accurate, the most reliable, the absolute gold standard is the pyramid of energy. This pyramid shows how much energy is actually flowing from one level to the next over a set period of time, like a full year. And this one illustrates a fundamental law of nature. The pyramid of energy can never, ever be upside down. It is always a true pyramid. And the reason for that comes down to one simple, incredibly powerful number. And that number is 10%. That's it. On average, only about 10% of the energy from one level actually makes it to the level above it. So where does the other 90% go? It's mostly lost as heat while organisms are just, living their lives, moving around, keeping warm, all that stuff. This 10% rule is like a law of physics for ecosystems, and it's what guarantees the energy pyramid always has its classic shape. Okay, we now have all the clues. We know what biomass is, we know how scientists measure it, and we've seen the three different types of pyramids. It's time. Let's go back to our original puzzle and finally put all these pieces together. So let's revisit that big mystery. How is it possible that in some marine ecosystems, the predators actually outweigh their prey? How can a pyramid of biomass be turned completely upside down? All right, here it is, the big reveal. In a normal ecosystem like a field, the producers, the grass, have a ton of biomass just sitting there, and they grow pretty slowly. But in the ocean, the producers are these microscopic things called phytoplankton. At any single moment in time, their total weight isn't actually that much. But, and this is the absolute key, they reproduce insanely fast. Some can double their entire population in a single day. It's that lightning-fast growth rate that makes it all possible. That's what allows a small, constant amount of phytoplankton to feed a much, much larger mass of zooplankton that reproduce way more slowly. Think of it this way. It's not about how much food is on the dinner table right now, it's about how quickly the kitchen can crank out more food. And that phytoplankton kitchen is running 24/7. And this brings us right back to the ultimate rule. Even though the pyramid of biomass in that ocean ecosystem is upside down, the pyramid of energy for that exact same system would still be a perfect upright pyramid. The flow of energy is always the same. You just can't cheat that 10% rule. Energy is always lost. So why is all this so important? I mean, it's more than just a cool diagram in a textbook, right? These pyramids are actually vital tools. By measuring changes in biomass and energy flow, scientists can literally check the health of an ecosystem. They can see the impact of pollution or track how endangered species are recovering. These pyramids let us read the vital signs of our planet. And that leaves us with one last thing to think about. We've seen how everything is connected, from the very bottom to the very top. So what do you think happens to the rest of the pyramid, to the animals at the very top, if you suddenly remove the producers from the very bottom? The answer to that really shows you just how fragile and how interconnected these beautiful pyramids of life truly are.